Okay, now moving on to the next part of the same question. A student is provided with three resistors of resistances 90, 45, and 20 ohms. Sketch a diagram showing how two of these resistors may be connected together to give a combined resistance of 30 ohms between the terminals shown. Label the values of resistances. Okay, now, so we have to use any two of these three values to give a combined resistance of 30. So we have two options now. Either any two can be connected in series or parallel, but we have to keep in mind that the resultant must be equal to 30 ohms. Now, for series connections, whenever resistances are connected, the total is always a value greater than the individual resistances. Why? Because the individual resistances simply get added up. We can take, for example, 45 and 20 here. If we add these two up, we get a total of 65 ohms when connected in series. Similarly, in parallel, when any two resistances are connected, the sum is always lesser than the individual resistances. So if I connect 45 and 20 ohms in parallel, their total will be a value lesser than both 45 and 20. Now we need a value of 30 ohms. So we can just keep adding these for series combination and see that none of the combinations will actually give us a total of 30 ohms. So we'll have to connect them in parallel. Now connecting them in parallel means we'll have to pick any two values which give us a total of 30 ohms. So connecting 45 and 20 will mean that the total will be a value lesser than 20 ohms. Connecting 90 and 20 will also mean the same. Now connecting 90 ohms and 45 ohms can have a total of resistance which is less than both 90 and 45, and 30 is a value exactly below 90 and 45, and we can check this by applying the formula for total resistance for a parallel circuit. Total resistance is R1 into R2 divided by R1 plus R2, and if you find the answer, it will be 30 ohms. So this is our correct circuit.